Hello viewers, in our last lesson we had learnt how to draw the graph for the system of linear equations. Can you recall how did we do that? Let's have a look at another system now. Now here the system with me is 7x minus 8y equals 11 and the other equation is 8x minus 7y equals 4. To get the ordered pair for both these equations, we make these equations into x as a subject or y as a subject. And here in both the equations I have made x as a subject. From the first equation, x I get is 1 over 7 times 11 plus 8y, and for the second equation x equals 1 over 8 times 4 plus 7y. And by assigning different values to y, we get the values of x. Supposing in this one I assign to value y 0, I get the value of x as 11 by 7. So first ordered pair is 11 by 7, 0. Second ordered pair is minus 5 by 7 minus 2. And third ordered pair is minus 13 by 7 minus 3. And similarly for this equation, I have ordered pairs as 11 by 8, 1, minus 3 minus 4, 1 by 2, 0. Now though it is possible for me to get the ordered pairs in integers, but that is too much time consuming process. And in case I get these ordered pairs, then what happens? It is practically very much difficult to plot the point 11 over 7, 0 or of the type minus 5 over 7 minus 2, minus 13 over 7 and minus 3. So that means there is a problem when we make the ordered pairs. Either it is too much time consuming, or if we get the ordered pairs in the fractions, it becomes difficult to locate them onto the graph paper. Now let's look at another problem. Here I have drawn the graph for the two equations, and the graph for the two equations are the first equation being 6x plus 7y equals 42 and the second equation being 2x plus y equals minus 4. The graph has been plotted. This is for the line 6x plus 7y equals 42, and for the other it is 2x plus y equals minus 4. Now here what you find? If I extend these lines this way, these lines won't meet, but they can meet if I extend them this way. But the graph paper, there is a limitation of the graph paper. They will intersect outside the graph paper. That means this graph paper is not sufficient to get the point of intersection of the lines. So there is another problem when we draw the graph for the system of linear equations. The system may be a consistent system, that is, if we happen to plot its graph, the lines will intersect, but the point of intersection may be outside the graph paper. Now let's have a look at another problem which we face in plotting the system. Now here the system has been plotted as 5x plus 4y equals 20. This is the line for that, and the other is x minus y equals 2, and this is the line for that. And can you recall how we get the solution for this? From the point of intersection we plot perpendicular onto x-axis and also onto y-axis. Now here I have already calculated the values of x as 28 by 9 and 10 by 9, which of course becomes very difficult to locate from this point of intersection after dropping the perpendicular onto x-axis and onto y-axis. So here we saw that when we plotted the graph for the system of linear equations, the various problems we came across. The problem could be that of the ordered pairs coming in the form of fractions, or the lines going outside the graph paper and intersecting outside the graph paper, or if the lines are intersecting in the graph paper, the ordered pair corresponding to the system may not be easy to locate. So that means naturally we need some other method to solve this system of equations, and the other methods are algebraic methods. Now in the algebraic method of solving the linear equations, you have already learned how to solve the linear equations in one variable. So that means when we are going to solve the linear equations in two variables, we'll be changing the equation into one variable, and then by the routine steps of calculation we'll do that. Let's have a look at a system of equations. The system of equations is 7x minus 8y equals 11, and the other equation is 8x minus 7y equals 7. For the first equation, I am making x as a subject. So x will be equal to 1 over 7 times 11 plus 8y, and for the second, x equals 1 over 8 times 7 plus 7y. Now remember here, if from the first equation I have made x as a subject, I will make the x as a subject for the second equation as well. But in case I am making y as a subject from the first equation, I will be making y as a subject from the second equation. So here we got x equals 1 over 7 times 11 plus 8y, and x equals 1 over 8 times 7 plus 7y. So since both these are representing the values of x, so 1 over 7 times 11 plus 8y equals 1 over 8 times 7 plus 7y. And on simplification I get 8 into 11 plus 8y, 7 times 7 plus 7y. Now we got these equations in the simplified form, and now we go ahead to get the value of y from these equations. Now here is the equation, 8 times 11 plus 8y equals 7 times 7 plus 7y. To open the brackets, we make use of distributive law, that is 8 times 11 is 88, and 8 times 8y is 64y. That equals 7 times 7, 49, and 7 times 7y, 49y. Now transferring the variable to one side, that is I get 64y minus 49y equals 49 minus 88, and from there I get 15y equals minus 39. And the value of y obviously is minus 39 upon 15, and that on simplification gives me minus 13 upon 5. So that is, you saw that first I converted both the equations into x as a subject, and from there I calculated the value of y. Now the question arises that how to get the value of x. Now let's have a look again. So this was a system, 7x minus 8y equals 11 and 8x minus 7y equals 7. We have already got the solution of y as minus 13 upon 5. Now this value of y can be substituted either in the first equation or in the second equation. Now here I have chosen the first equation to substitute the value of y and get the value of x. So 7x remains as it is, minus 8 times the value of y is minus 13 by 5, and that I have written over there, that equals 11. This on simplification gives me 7x plus 104 upon 5 equals 11, and from there 7x equals 11 minus 104 upon 5, which gives me minus 49 upon 5, and therefore the value of x will be minus 49 upon 5 divided by 7, and that gives me minus 7 upon 5. So that is the way how I got the values of x and y. Now this method where we eliminate one of the variables is called method of eliminating the variable. Now can we think of some other method also? Yes, we have other methods also for solving the system of linear equations. So let's have a look at this system. This system we talked about just now. This is 7x minus 8y equals 11 and 8x minus 7y equals 7. The value of x I got was minus 7 by 5, and value of y is minus 13 by 5. Since I am getting unique value of x and that of y, this system is a consistent system. And we are talking of that whether can we have any other method of solving the linear equations? Yes, of course we have. Let us see what that method is and how do we go about that. Now here we have to solve for 15 upon u plus 2 upon v equals 17, and the other equation is 1 over u plus 1 over v equals 36 upon 5. Now here the system is not a linear system. The first equation is not a linear equation, and the second is also not a linear equation. So what I need to do? I need to convert first it into a linear equation, and for that purpose what I will do, I will say let us set 1 over u as x and 1 over v as y, so that this system 15 upon u becomes 15x plus 2 upon v becomes 2y equals 17. And the other equation was 1 over u plus 1 over v equals 36 upon 5. That equation takes the shape x plus y equals 36 upon 5. Now I have got these linear equations, and from there I will get the values of x and y. Now here I am following the other method, that is I am not eliminating the variable, but I will be making the coefficients same. See once again the equations are, let us have a look at the equations once again. The equations are 15x plus 2y equals 17, and the other being x plus y equals 36 upon 5. Now I can eliminate x or y from these two equations. If I intend to eliminate y, I will have to make the coefficients of y same for both the equations. Now here in the first equation the coefficient of y is 2, whereas in the second equation the coefficient of y is 1. And you know that in an equation if we multiply it by a certain number, the equation does not change. So let us multiply the second equation by 2, and the first equation we are keeping as such, that is either we are multiplying it by 1. So the first equation remains same, that is 15x plus 2y equals 17, and multiplying the second equation by 2, I get 2x plus 2y equals 36 upon 5 into 2, that makes it 72 upon 5. Now to get rid of y, I will have to subtract these two equations. On subtraction, 15x minus 2x will be 13x, and 2y minus 2y will go 0, and 17 minus 72 upon 5. For your convenience, when you are subtracting, you can put the signs, change sign downwards. Here this is minus and this is minus. After getting 13x equals 13 upon 5, I get the value of x 13 upon 5 divided by 13, that gives me the value of x as 1 upon 5. But here remember one thing, when you have made the coefficient same, after that you have to take the precaution, in case their signs are same, that is either they are having the plus sign or both of them are having the minus sign, then you have to subtract. But in case they have the different signs, then you simply add up and you can get rid of one of the variables. But here our main equation was not in terms of x and y. I had changed the equation into a linear equation for my convenience by writing 1 over u as x and 1 over v as y. So let us see then how do we get the value of u and v. So 15x plus 2y equals 17 and x plus y equals 36 upon 5. I have got the value of x, that is 1 upon 5. But prior to getting the values of u and v, I have to get the values of x and y. Value of x I have already obtained, and to get the value of y, what do? I put the value of y in one of these equations, either this or this. Now here you have to be little careful that which equation looks convenient to you, only that equation should be taken. Now here obviously x plus y equals 36 upon 5 is a more convenient linear equation. So I substitute the value of x as 1 over 5 in this equation. For x is 1 over 5 plus y remains over there and equals 36 upon 5. And from here y equals 36 upon 5 minus 1 upon 5, that is 35 upon 5, and y is 7. So solving these equations for x and y, I got the value of x as 1 upon 5 and that of y as 1 upon 7. But can you recall what was my original equation? The original equation was 15u plus 2 upon v equals 17 and 1 upon u plus 1 upon v equals 36 upon 5. This was changed into linear equation for my convenience by substituting 1 over u as x and 1 over v as y. So first equation took the shape 15x plus 2y equals 17. And how about the second equation? Second equation was x plus y equals 36 upon 5. Since 1 over u has been taken as x and the value of x has already been obtained as 1 over 5, from there I get the value of u as 5, and 1 over v was taken as y and the value of y we obtained is 7. From there I get the value of v is 1 over 7. So, solution is u is equal to 5 and v equals 1 over 7. So, once again you can see, because I am getting a unique solution, that is unique value of x and u and v. So, this system is nothing else but a consistent system. So, here in this method what we learnt, that to get the value of the variables I equated the coefficients and then went ahead by solving for another variable. So, prior to doing that we have to decide that which variable we want to get rid of. Let us take another example and see. Here the equations are x plus 2y equals 4 and 2x minus 3y equals minus 6. Now, supposing once again I want to get the value of x. In an attempt to get the value of x, I will have to get rid of y, that is right. And how do we do that? To get the value of y, I will have to make the coefficients of y in both the equations, that is first equation and the second equation same. Now, here the coefficient of y in the first equation is 2 and in the second equation is minus 3. So, what I am supposed to do? I have to multiply the first equation by 3 and second equation by 2. So, multiplying the first equation by 3 I get 3x plus 6y and 3 times 4 is 12. Second equation has been multiplied by 2. 2 into 2 is 4x, 2 into minus 3y minus 6y and 2 into minus 6 is minus 12. Now, here what do you find? I have made the coefficients of y same. Here it is 6 and here it is 6. Then I am supposed to look at the signs. In the first equation the sign for y is plus and for the second it is minus. So, what should I do? Should I add them or subtract them? Now, just now we talked to you, in case they are having the different signs, you are simply supposed to add them. So, adding this equation to this, I get 3x plus 7x, 3x plus 4x equals 7x, 6y and 6y being of the opposite sign, their addition will give us 0 and 12 plus minus 12 will also 0. So, that gives me the value of x as 0. Substituting this value of x in any one of the equations, that is either this equation or this, I can get the value of y. So, here I am substituting the value of x, which is 0, into the second equation. So, what do I get for that? 2 times 0 minus 3y equals minus 6, and that gives me the value of y as minus 6 upon minus 3, that is equal to 2. So, here again we got the value of x as 0 and y as 2, and how did we get that? By making the coefficients of y same. So, that is the way we can solve algebraically linear equations. But can we think of some other convenient way? Yes, we have another convenient way, and for that I am taking the equations in the general form. The equations are a1x plus b1y equals c1 and a2x plus b2y equals c2. Now, in case I want to get rid of y, that is I want to solve for x first, so I will have to make the coefficients of y same. So, multiplying the first equation by b2 and second equation by b1. Remember, first equation I am multiplying by b2, that is the coefficient of y in the second equation. So, first equation becomes a1 b2 x plus b1 b2 y equals c1 times b2, and the second equation becomes a2 b1 x plus b1 b2 y equals c2 b1. Now, here the coefficients of y in the first equation is b1 b2 and the second equation is also b1 b2. What about their signs? Both of them are same signs, that is plus in this case. So, what I need to do? We have to subtract. On subtraction, I will get a1 b2 minus a2 b1 times x equals c1 b2 minus c2 b1, and from there I get the value of x as c1 b2 minus c2 b1 upon a1 b2 minus a2 b1. So now the question arises that I have to get the value of y. So that can be done either by substituting the value of x in any one of the equations or following the same method which I did right now. Here, since I want to get the value of y now, I will make the coefficients of x same. So multiplying the first equation by a2 and second equation by a1, I will get this equation a1 a2x plus b1 a2y equals c1 a2, and the second equation becomes a1 a2x plus b2 a1y equals c2 a1. Now here the coefficients of x have been made equal, and the sign you can see. What is the sign for these? Both are positive. So that means again I will have to subtract, and from there I get a1 b2 minus a2 b1 times y equals a1 c2 minus c2 a2 c1, and from there I get the value as value of y as this. But in case we have to go like that, can we have another convenient way? Yes, we have. So here, taking the equations, we write x, y and minus 1. So remember here, when you are writing minus 1, both the constants c1 and c2 should be onto the right hand side of the equality sign. c1 is on the right hand side and c2 is also on the right hand side. Below x, we write the coefficients of y, that is b1 from here and b2 from there. Then constant terms which are c1 and c2. Then y, this is the coefficient of x, and this is the coefficient of x from the second equation, and then we repeat the coefficients of y, that is b1 and b2. Then how do we get the value of x? For getting the value of x, we will go down like that. From this product, I will subtract this product. So that becomes x upon b1 c2 minus b2 c1, and here the product of c1 a2, from this product I will subtract the product of c2 a1, and for minus 1 upon, I will take away the a1 b2 product of this minus a2 b1. So here we get a generalization for that, how we can solve for x and y. Let us take a particular example and apply this method. The equations here are 2x plus 5y equals 13 and 2x plus 3y equals 4. And how do we write the coefficients? First that of y, that is 5 and 3, then constant terms, then that of x, and then the coefficients of y. So how do we go about? This will be x upon 5 times 4 is 20, here is that, minus 3 times 13, that is 39. So that is x upon 20 minus 39, and from y upon 13 times 2, that is 26, that is over here, minus 4 times 2, that is 8, and minus 1 upon 2 times 3, that is 6, and minus, we will take away the product of 5 and 2, that is minus 10. So from here I get the x upon minus 19 will be minus 1 upon minus 4, minus 1 upon minus 4, that makes it 1 upon 4. So the value of x we get is minus 19 upon 4, and the value of y I can obtain from here, that is y upon 18 is equal to minus 1 upon minus 4, that is 1 upon 4. So value of y comes as 18 upon 4, that is 9 upon 2. So in this method we found that it is quite labor saving device, and we can very easily get the value of x and y, and this method we term it as cross multiplication method. Let us have a look at other equations. The equations are 3x minus 2y equals 4 and 6x minus 4y equals 8. Setting the coefficients once again, x, y minus 1, and here I have set the coefficients as it was told to you earlier. So the product of minus 2 and 8 minus the product of minus 4 and 4, that becomes minus 16 plus 16. Similarly, 4 times 6 minus 8 times 3, that becomes y upon 24 minus 20, that is also 0, and 3 into minus 4 minus 6 into minus 2, that makes it plus 12, and that is also 0. So here what do you find? That x upon 0 is equal to y upon 0 is equal to 1 upon 0. So if x upon 0 is equal to minus 1 upon 0, I will get from there x into 0 is equal to 0, and this is true for all values of x. Similarly, from y upon 0 and minus 1 upon 0, I get y times 0 is equal to 0, and this too is true for all values of y. So here in this case, we will find that we will get infinite solutions of x and y, or what did we call this system as? This system was termed as consistent system with infinite solutions. So here let us take another case now. The equations are 2x plus 3y equals 4 and 4x plus 6y equals 5. Setting x, y and minus 1 and the coefficients, I get x upon 15 minus 24, y upon 16 minus 10, and minus 1 upon 12 minus 12. 12 minus 12 is not 0, is 0, minus 1 upon 12 minus 12, that is 0, 16 minus 10 is 6, not 0, 15 minus 24 is not 0. So that is here what I got, x upon minus 9 is equal to y upon 6 is equal to minus 1 upon 0, and if I take x upon minus 9 and minus 1 upon 0, I get x times 0 is equal to minus 1 times minus 9, that gives me 0 is equal to 9. Now is it possible that can 0 be equal to 9? No. Similarly, y into 0 is minus 6, which is also not possible. So this system here is inconsistent system and has no solution. So let us have a general look. So here the equations are this, and we get the values of x as b1 c2 minus this upon a1 b2 minus a2 b1, and value of y is minus a2 c1 minus this upon a1 b2 minus a2 b1. Now here let us take the case. In case this is equal to 0, then I get a1 upon a2 is equal to b1 upon b2, and b1 c2 minus, if b2 c1 is 0, I get b1 upon b2 is equal to c1 upon c2, and same thing I get from there. And this system, when we are having a1 upon a2 equals b1 upon b2 equals c1 upon c2, the system is consistent with infinite solution. But in case I get a1 upon a2 equals b1 upon b2 but not equal to c1 upon c2, such a system is inconsistent and has no solution. So viewers, today we saw how to solve the system of equation algebraically and to test whether the system will have unique solution, infinite solutions or no solutions.